All right, hello everyone. Today I'll be talking about the Machine Learning Foundations course for Duke University that I did on Coursera. Some of the background is we're trying to analyze energy output of a power plant using four input variables. Input variables include temperature, ambient pressure, relative humidity, and exhaust vacuum. And we're using those input variables to predict the energy output. There are 9,568 observations, which we have in our data set. Some of the things that we're considering is which model to use, which features to use, what evaluation criteria to use, and how do we interpret the output of the model and determine the winner, and how do we communicate that performance. So the approach that I took is really starting with the data set, try to identify if there are major outliers. There were some outliers, but they were not super significant for each of the variables. But what I did do is I reduced the decimal point value from 100 decimal points to 10 decimal points because I felt like it reduced some of that noise and reduced kind of the size of the data as well. The second thing I did was upload the data set to Google Colab, where I coded in Python to run the analysis, run the regression model. From there, you import the data set, import the libraries that you need to use, label the dependent variable, independent variable. So the dependent variable in our case is energy output. That's what we're trying to predict. And the dependent variables include temperature, ambient noise, ambient pressure, exhaust pressure, and relative humidity. So the best machine learning model for this approach, for this test, was really going to be a regression. Just based off of the use case, the decision trees didn't really work because there was a classification. Some other things like lasso didn't work because we didn't have enough data or we had too much data. So really regression based off of the problem was really the best approach. And we did a multiple regression. As far as understanding what features to use, so starting off, I tested the model using all the four features here. So I'll go into explain my code a little bit. So first I uploaded the data here in a CSV, and then I classified what my output variable was going to be, which is going to be energy output. And then I split the training, the data into a training set and test set. So 80% training and then 20% test. I ran a linear regression on it. And then I measured three KPIs: mean squared error, mean absolute percentage error, and mean absolute error. So the first model, which had all four variables, had an output of this, which I'll talk about a little bit later. And then next was really trying to determine how do I optimize this model. So what I did is I created, I'm going to go back to PowerPoint, Word here. What I did is really do like a simple correlation, trying to identify which variable had the highest, the biggest or lowest correlation. So from this, just identify that humidity had a 0.39 positive correlation to energy. So I kind of wanted to test this. If I remove humidity from the model, how would the model perform? So I went ahead and removed humidity based off of this. Created a plot here, and then I went back to Google and I did the same thing, tested the model again, but this time removing humidity from the model, from the independent variables, excuse me. I did split the data set into 80-20 again, and then I measured the same three KPIs, and I charted those here, and I created a simple plot, but won't discuss the plot too much. But going back here, so the first approach was, again, trying to run a linear regression with all four input variables, measure their KPIs, and then run the model again, removing the humidity and measure those KPIs. So we saw that based on model 1 and model 2, model 1 performed best. So the lower these numbers are, the better. Model 1 performed better in two of the KPIs, and the third KPI, MAPE, mean absolute percent error, was the same across both. There's really no statistical difference between the two. So from this, we can conclude that model 2, a linear regression model, model 1, a linear regression model with all four independent variables, is best at predicting energy output. Yeah, that's it. Thank you.